Hello guys, welcome you to my channel on the course of linear algebra in the perspective to crack CSIR NET in mathematical science or GATE. Please like and subscribe this channel so that in future uploaded videos you will be notified. So this is class 4C because theoretical parts I have already discussed in class 4A and 4B on linear transformation. But today I am not going to tell about any theoretical part, rather I will solve some previous year's questions. Maybe it is in GATE or NET, that year I don't remember exactly, I just randomly choose the questions. Let's see. The first question is, MNK denotes the space of all n cross n matrices with entries from a field K. Fix a non-singular matrix A and a linear map T on MNK such that T of x equals to AX. Okay? Here x is not a vector because x are from MNK. And options, you can see the options are based on trace, rank, singularity or non-singularity. Means what you require? You first find the matrix representation of this linear map with respect to the basis of MNK. Now, for simplicity, let's choose n equals to 2. Then, this is the basis vectors of M to K, where you know E11 is 1, 0, 0, E12 is 1 is in 1-2th element, like this. 2, 1 is second row, first column is 1, rest are 0. So E2, 2 now you know, it's 0, 0, 2, 2 element is 1, rest are 0. So you need to find this matrix representation of T with respect to beta. To do that, now T of E11, it's your A E11. Let A equals to A11, A12, A21, A22. And date A not equals to 0. That means A11, A22 not equals to A12, A21. Okay? Now TE11 is nothing but your A11, 0, 0, 0. Similarly, T12, 0, A12, 0, 0. E21, 0, you can check it, but it's very easy. Just multiply this with the 1, 0, 0, 0 for E11 and T E22. Okay? Now, in matrix representation, I told you T of Vj, where Vj's are basis from the domain of T, equals to summation Aij Wi, where Wi's are the basis of the codomain set. So, for Tv1 means Te11, we can write Te11 in the form A11 E11 plus A12 into 0 plus A21 into 0 plus A22 into 0. Similarly, you can write Te12 0 E11 because your first row second element is only A12. And like this you can go. if you proceed like this, the matrix representation of T with respect to beta will be your F means TE11 coefficients are like A11 0 0 0 and T of Vj summation of Aij Wi. So this will come as column. Now you get the trace. Trace is the sum of all the elements of the matrix A. So option B is true. Now rank. Rank is all the columns are independent. So rank of T beta equals to 2 square 4. That you can write 2 square. Where not square you don't think of. This 2 is coming because you have considered n as 2. So rank is n square. Now T is non-singular. Is it non-singular? Let's think of it. For non-singularity, date of T beta not equals to 0. But if one of the elements of this A, maybe you have forgotten, if any of the elements of this A is 0, then the determinant of this matrix representation will be 0. But if we consider suppose this one, then A is non-singular, but determinant of TB becomes 0. So we cannot say about the singularity or non-singularity of T from this perspective. These two options are correct. Next, let's go to the next problem. You read the problem first. A linear transformation T rotates each vector in R2 clockwise through 90 degree. Clockwise means the vectors are rotating like this. Correct? Now, the matrix T relative to the standard order basis. What is the? So, T rotates each vectors by 90 degree. 1 0 is here. If we clockwise go, then it will be like 0 minus 1. T of 0 1. 0 1 is here and it is clockwise, it is moving, then it will be 1 0. So 0 minus 1 we can write it as 0 because with respect to standard ordered basis we have to mention plus minus 1 into 0 1. This we can write it as okay. So matrix of T with respect to standard ordered basis is what? This one will become as column. This one again as column. 0 minus 1 1 0. So option B is your correct option. I hope you are understanding these problems. It's not difficult, but to do that you must have the basic knowledge and deep knowledge, I can say. Okay. Let's coming to our third problem. What is that? Let n be a positive integer and V be an n plus 1 dimensional vector space. N plus 1 dimensional vector space means I can think of this one. If E1, E2, En plus 1 is a basis of V and T, V2, V is a linear operator, V2, V is a linear operator, and it is given that T of Ei equals to Ei plus 1 and T of E n plus 1 equals to 0, then which options are correct? Trace, rank, nullity, t power n. So again you need to go for matrix representation of t. Let's do that. And let's suppose n equals to 2 for simplicity. So t of e1 is your e2, t of e2 is 0. This can be written as 0 e1 plus 1 e2, 0 e1 plus 0 e2. So matrix of t with respect to this basis 0 1 0 0. So trace of t is non-zero. No, trace of t is 0, because you know mathematical induction, if it is true for n equals to 2, then it must be true for n. This is not correct. Rank of t is n, but we are getting rank of equals to 1 equals to 2 minus 1 equals to n minus 1. So option B not true. Nullity of t is 1. Yes, from rank nullity theorem we can say, since rank of t is n minus 1 and n plus 1. Nullity of t is 1. Okay, rank of t is n minus 1 and dimension of v equals to n plus 1. So nullity of t is coming as n plus 1 from rank nullity theorem. Remember, it is coming as 2. So option C is also not true. Let's take about t to the power n. T square e1 equals to t of t e1. T e1 is e2. T e2 is 0. T square e2. T of t e2, that is 0. T of 0 is always 0. So option 4 is the only correct option. T to the power n is the 0 map. None other options are correct. The students generally mistakes here. They thought, okay, dimension n, it is n minus 1, so nullity of t is 1. No. That's why I pick up this problem. Let's go to next one. It probably get 2021 question. Yes, it is 2021. What is that? T R3 to R3 be a linear transformation such that T of 1 1 1 is given as 1 minus 1 1 and t square 1 1 1 is 1 1 1 and t square 1 1 2 is also your 1 1 1. Okay. Now as t is linear transformation, so by composition we can say t square is also a linear transformation. Okay. Now let's just subtract these two. T square 1 minus 1 0, 1 minus 1 0, 1 minus 2 minus 1 equals to 1 minus 1, this one, then this, then this, so 0. So here you can see, nullity of t square is 1, because you have 0 0 minus 1 or 0 0 1 you can say, and by multiplying it any scalar you will get 0. So rank of t square, what will be that? Here dimension of R3 is 3. So rank of t, and as t from R3 to R3, so t square is also from R3 to R3. So rank of T square is 2. Now rank of T square is less than equals to rank T, because in matrix sense you can think of rank of AB is less than equals to rank minimum of rank A or rank B. That's why I say rank of T square is less equals to rank T. So rank of T is greater equals to 2, but as dimension of V is 3, rank of T is less equals to 3. So what we get? Rank of T is either 3 or 2. Okay. Now if rank of T is 3, then T is 1 to 1 and on 2. So T is invertible. T is 1 1 and on 2, because it is a finite dimensional vector space. So rank T is 3 means nullity of T is 0. That's why this implies T inverse exists. If T inverse exists, then what will happen? Just a minute. Okay. Now T inverse exists and rank of T is 3. So if T square equals to I, but okay, earlier you get T square 0 0 minus 1 equals to 0 0 0. I forgot. Sorry. 0. Since T inverse exists, so T of 0 0 minus 1 but T is 1 to 1 means T inverse, as T is invertible, so T inverse is also 1 to 1. So this is 0 0 0. This implies nullity of T equals to 1, but here it implies nullity of T equals to 0. So we are coming to a contradiction. And so rank of T equals to 2. You understand this contradiction part? Suppose rank of T is 3, then nullity of T is 0. But you have T square of this 0. Then since T is invertible, multiplied by T inverse. So T of this is this. But as T is 1 to 1, so T inverse is also 1 to 1. So T inverse 0 is nothing but 0. But as you are getting T of some element other than 0 is 0, so nullity of T must be 1. It cannot be 0. That's why contradiction is coming. Okay. It's a big question. Let's see what it is. It is also a get question. Let P2 be the vector space of all polynomials at most 2 over R. So dimension of P2 equals to 2 plus 1 equals to 3. Let a linear transformation T P2 to P2 be defined by this. Now which of the following are true? The null space of T is this. Let's set T. What's wrong? T minus alpha plus alpha x plus alpha x square. So here A equals to minus alpha, B, C are alpha. This is equals to A plus B, 0. B minus C, 0. A plus C, 0. So the null space of T is this. Correct. Now T is defined on a finite dimensional vector space P2, and null space as you got, so nullity of T or kernel of T is 1. Okay, as long as kernel of T is 1, so rank of T you can say it is 2. That you can also check. Here you have given T is spanned by the set this. Let's see. T equals to A 1 plus x square plus B 1 plus x plus C x square minus x. This can be written as A 1 plus x square plus B 1 plus x plus C x square plus 1 minus 1 plus x. So T is completely generated by the sets 1 plus x square and 1 plus x. So option 2 is also correct. Now when these two are correct, just look at the options given. 1, 2, 1, 3, 4. No, B is wrong because 2 is correct. 2, 4. No, 1 is also correct. So 2 options are gone. Now we have to look on option 3. So we have this one not true, this one not true. Now what about option 3? T of T composition mapping equals to T. Now T of 1 plus x means your A equals to 1, B equals to 1, C equals to 0. So 2 plus x plus x square. When this is coming, then your A equals to 2, B 1, C 1. This is equals to A plus B 3 plus B minus C x plus 3x square. So this is not coming as 1 plus x square. So option 3 is wrong. Option 3 is wrong. Now check about option 4. Let's see. So option 4. If M is the matrix representation of T with respect to the standard basis 1x x square of P2, then the trace of the matrix M is 3. So you need to find the matrix representation of T with respect to this standard basis. So T of 1 means A equals to 1, B 0 and C 0. So it is nothing but 1 plus x square. This can be written in terms of standard basis like 1 into 1 plus 0 into x plus 1 into x square. T of x means A is 0, B is 1 and C is 0. So it is 1 plus x. This can be written as 1 into 1 plus 1 into x plus 0 into x square. Now T of x square. A is 0, B is 0, C is 1. So minus x plus x square. This can be written as 0 into 1 plus minus 1 into x plus 1 into x square. So matrix representation of T with respect to this ordered basis beta equals to 1, 0, 1, 1, 1, 0, 0, minus 1, 1. So trace of this equals to 3. option 4 is correct. So your choice is C. It's done. I have solved some important questions here which are appeared in previous exams. I hope you have enjoyed this lecture, but try to practice more. As much as questions you will solve, you will be confident and you will have the ability to solve any questions that come in exams. Thank you very much. Hope you will subscribe my channel.